Hello everyone, and thanks for watching this video. This is Sabiuddin Ahmad Siddiqui. I will be introducing you this subject, Computer Science, component code 0478 IGCSE O level. Before we proceed any further, I would like to introduce myself. Basically, as far as my credentials are concerned, I have done masters in computer science. Before doing that, I have done diploma in computer science, and then before that I have completed my bachelor's in commerce. I have been associated with this field for more than 16 years with the Beacon House School System, O levels computer science, OA level computer science, the City School OA levels computer science, and the computer applications is basically I have been associated with AppTech Computer Education for computer applications such as Java, Android, C#, VB.NET, SQL, ASP, and recently I have been associated with Edupedia World, which provides the education, and I have been the one who is developing the videos for Java applications. So you can see the brief introduction about my profile. So moving on to the topic, I have chosen number systems. This is known as data representation. Now you can see, first of all we will take a look on binary system, and then we will come to hexadecimal. Now as far as binary number system is concerned, we have to take a look on this system, that the number system with digit range, what it actually shows. First of all, binary. Before we understand binary, try to understand that binary means 0 and 1. The string of binary, that means the microprocessor understands binary language easily than the high level language, that is known as English. Now you can see the range, the digit range, it includes 0 to 1, that means 0 and 1 only. If you try to make it understand that 2 should be there, so you have to just convert it into 0 and 1 form, or you can say that the 0 1 form represents that they are the type of signals. 0 means off and 1 means on. The microprocessor executes on the instructions whose state is 1, and if you talk about states, that means 0 and 1. You can see the base or radix, which is written after the brackets. The number of binary is 10110, and you can see the base is 2, or it is also known as radix. When you convert this number, you need to know some other technicalities which will coming ahead. The second type is decimal or denary. Why I have included? To make you understand that, for example, in daily life we deal with the numbers which are countable, that is 40, 70, 80, 90, and any type of number. Let's suppose 1400, and let's suppose all the digits which need to be converted into binary must be known to you, that is 0 to 9, which makes 10. Now how do you know that they are 10? 0 will be counted as 1, 1 will be counted as 2, 2 will be counted as 3, and so on till 9. When you reach on 9, it becomes 10. You can see the base with the number which needs to be converted into binary, or if the number is written in the form which I have written in the base or radix column, that is 27, and you can see the base is 10, which is in orange red color. Now coming on to hexadecimal, it has two categories. The first one is numbers 0 to 9 and the second one is hexacharacters A to F. Now if you see that A equals to 10, B equals to 11, C equals to 12, D equals to 13, E equals to 14 and F equals to 15. So in this regard, the total 16 digits or 16 numbers including characters, that is why I have divided. You can see that the division you will find everywhere. The numbers 0 till 9 and hexacharacters. Hexa stands for 6, that is why they are only 6 characters, A till F, with different values. How to write this? Let's suppose the hexadecimal number is 2FE6. Now you can notice that the 2 is decimal and 6 is decimal, but you can write in the first series of hexadecimal, that is known as 0 to 9. The next one is the FE, which is the hexa special characters, which are the combination of the hexacharacters type 2 category 2. Now you can see that the 2FE6 with base 16, as I have already told you that 16, which is written in orange red color, is a base. You can recognize the number with this base, or if it is not written, then you can just catch the information with the words or characters written with the numbers. If they have this type of number, definitely they are hexadecimal. The base is represented in orange red color, if you are already well aware of this thing. Now moving on to how to convert from decimal to binary. Now see, before we proceed, we need to know the memory table and the binary notation table and how the numbers are formed. You can see that the information is stored in the memory locations and the value which will be calculated is known as value. Now if we want to consider memory table, it has 2's value. That means the values will be generated on the basis of 2's power. 2 is from the binary, which is base 2, and the power as increases, the value will be increasing gradually, or you can say the value will be increasing respectively. For example, if 2 raised to the power 0 will give you 1, if 2 raised to the power 1 will give you 2, if 2 raised to the power 2 will give you 4, and so on till 10. You can see the exact value or the combination, or you can just count if you are not understanding this. So you can understand the way. Let's suppose you are doubling the numbers. 1's double is 2, 2's double is 4, 4's double is 8, 8's double is 16, and so on till 1024, and so on till any most significant bit. The first value which you see with the 0 is known as least significant bit, LSB least significant bit, or LSD least significant digit, which will remain only 1. It cannot be lesser than this, which is known as LSB, the first part which is written under the 0. The location is 0 and the digit value is 1. Now the most significant digit is 128. You can increase the size of the bits. As the bits are increasing, the value will automatically be increased. It will start from right hand till left hand. Let's suppose 0, 1, 2, 3, 4, 5, 6, 7. These are the 7 locations having 7 powers of 2. Now if 2 raised to the power 0, it will give you 1, and so on. Hence the most significant bit is reached. Now you are not limited to use only 1 byte, that is 8 bits. You can increase the numbers or bits accordingly as per the need arises. So you can see that the least significant, which remains 1, and the most significant bit, which can be increased according to the number when it is required. Now you can see in the red block that is known as binary digits, again reminding you that 0 means off and 1 means on. Now moving on to the next slide that will guide you how to convert binary numbers. You can see the number. I have seen the number here. Now you can see this slide where we are converting from decimal to binary. You can see the symbol value is 56. Now convert 56 base 10 to parenthesis open, and you can see the 2 is base written. That means you are required to convert 56 into decimal. Sorry, binary. 56 to binary. Now symbol value is 56 for denary, which is to be converted into binary. Notice that the denary number 56 base 10. Now you have to count total from the position values and mark 1 under the values. You need to calculate till you get 56. Rest of the blocks will be filled with zeros. Now let's suppose you can see the position values which are written in mid blue color, and then the symbol values or placed value which will be demonstrating right now. Now you can see that. Now 32, you have to count 32, as you know that the 1 will be marked as on. So the instructions which you are going to count should be marked 1. First is the 32, 16 is the second, which makes 48. Then 8 if you add, then it becomes 56. 16, then 8. First mark those bits which you require number from. Let's suppose 32 plus 16 48, and 48 plus 8 equals to 56. Now you have got your answer. Now the rest of blocks will be filled with zeros, and you have to write the whole 8 bits number to the empty bracket or parenthesis which is written with the base 2. Now see, the rest of the blocks will be filled with zeros. Now this is the number you have converted into binary. Now the equivalent of 56 base 10 to binary is 000111100. From right to left you will count, you will start filling the parenthesis from right to left. So make sure whenever you are converting from this binary table, so you have to focus on that you have to fill in the leading values. You can omit the trailing values. So you can see that the 0 will be put first, then the second 0, then the third 0, and then the 1 written under 8, then 1 again written under 16, then 31 again written under 32. This is basically 6-bit number which you have formed. Now 64 and 128 will go empty with just filling the zeros. Now you can see the number appears here, 000111100. So this is the conversion of binary which you see just now, that how binary conversion is done from decimal. So this is the simple method which is very easy, and you can practice more and more to make yourself master. Moving on to the other part, that is binary to hexadecimal. Before we move, we have to verify, yes, that is the number okay. 32 plus 16 plus 8 and plus equals to 56. Yes, yes it is. Now you can just verify by again highlighting this. See, 32 comes here, then 16 comes here, then 8 comes here. Now all three values you have added now will give you 56. So this is the method you have verified that yes, 56 is converted into 000111100. From right to left, always remember that, from right to left. Now you can grasp the method by seeing this. Now see 16 and 8. Now this orange border has highlighted that these are the main blocks which you have to turn on while counting 56. Now you can see 56 again, 32 plus 16, 48, 48 plus 8, 56. So this is the method for converting from decimal to binary. Now converting from the binary to hexadecimal, the next method. Now you can see that the number, binary number is given, that is 0 1 0 1 0 0 1 1 1, and this is also known as binary string. Binary string means the sequential digits arranged in a binary string. That means each digit has some value. If the value is operated at different locations, so the number or the instruction will be changed. So make sure that each number is written in a correct sequential order. Notice that the binary string is in a form of sequential binary digits. You are required to make a pair of 4 bits. That means that each hexadecimal number and a binary number is formed into 4 bits. You have to remember this thing. For every instance, just draw the 4-bit table 1 2 4 8 and then start putting the symbol values which are 0 1 0 1. So if this is any type of number or any type of big binary string, so you can just chop them down into 4 bits of pairs. Now from right to left means you will start making a pair of 4 digits from right to left. That means the first pair will be created from right to left, that is 0 1 0 1 one pair. Then again you can see that and put it under a nibble. Nibble stands for half byte. A hexa character is formed in 4 bits, and again a hexa character is formed in 4 bits. So you can see that when I start showing you the demonstration, you will see that how this is done. Now you can see the 4 characters. I have created a pair of 4 bits, that is 0 1 0 1. One digit is formed. Then the orange underline shows you the pair, one pair of 4 digits or 4 bits. Then second pair, you can see the second orange line here appears to show you the second pair of the hexadecimal converted into 4 bits, 0 0 1 1, and the third one is left. Now what you are required to do, you have only one. So if you are putting one, it is okay, but remember that if you are not confirmed about, just put zeros by your own and then make a set of 4 bits. So if you do not put the zeros, doesn't matter, but it will come on the very first bit, that is known as LSB. Yeah, remember that. But if this 1 comes in the last, that means if this becomes the 4th bit, so you have to write the zeros first to make the pair of 4 bits. As I have told you before, that leading zeros cannot be omitted. Now see 3 and 4. Now this is the pair, this becomes the pair of 4 bits. Now we have 3 digits to form, that is 0 1 0 1, 0 0 1 1 and 1 0 0 0 from right to left. Again remember that from right to left. Now symbol value is 0 1 0 1 0 0 1 1 1 base 2 for binary, which is to be converted into hexadecimal. See the table of hexa for binary conversion. I have divided this number into 3 blocks: pair 1 of 4 bits, pair 2 of 4 bits and pair 3 of 4 bits, depending upon the total number of 4 bits pair. Let's suppose I have 3 pairs, so I have divided that into 3 pairs. So this is why you can see easily. Now if the number is greater than this or having more than 4 bits, more pairs than 3 pairs, we have 3 pairs right now. So if the number is lengthy or greater in length, so you can again make some more pairs of 4 bits. Now see 0 1 0 1, the first one, the first pair is put into the symbol in the place of symbol values, which are also known as placed values. Position values, as you know that if the position value, if the 1 is written under position value, which let's suppose 1 2 4 8, so the number which is in the position values will be counted where the 1 is written, Now you have seen that one digit is formed, that means one pair of 4 bits is filled in the symbol values row. That 1 0, that one position value, then we have 1 2 4 8. You can see that 0 is written under 1, 1 is written under 2, 0 is written under 4, and 1 is written under 8. So you have to count only 8 and 2. 8 plus 2 equals to 10. So you can see that 8 plus 2 equals to 10. Now see, 10 means A in hexa, which means that A should be written there. So this becomes A. Yes. Now A comes here. Pair 1 is done now. Now you can see the second part, which is 00 11. Now see the demonstration. Pair 2 of 4 bits will be working. See 0 0 1 and 1. This makes 12. This makes 12. 1 2 4 8. The number which is written under 4 is on, that is 1, and the number which is written under 8, which is on, that is 1. So 8 plus 4 equals to 12. So what is the code of 12? So you can see the digits and characters there. C is the 12. C has value 12. So you can see the 12 is formed, and the character you have to write there. C, and now C is formed. Now the last part is 1 0 0 0. 1. See, 1 is filled. If this 1 I want to fill it here, so definitely I cannot omit the leading zeros to make this 1 put here at the 8th position. That means at the notation becomes 8, 2 raised to the power 3, right? So this becomes 8. So because it is on the very first line, that is LSB, least significant bit, so it can go as it is. And if I want to omit zeros, I can do this. But to make you understand that if you are making a pair of 4 bits again, then you have to fill in all the empty blocks with zeros, whether they are definitely, if they are not leading, if they are the trailing blocks, so you have to fill in with the zeros to continue with the problems and to avoid the problems. Otherwise, if you are perfect enough, so you can omit these trailing zeros, but remember that leading zeros cannot be omitted. Then 0, then 0 again. So you have formed 3 binary numbers into hexadecimal. See the number representation, the second part of hexadecimal, or the first part of the hexadecimal, that is number, and the second part is the characters. Now 1 is formed, so you can see that 1 appears there, and now in this regard you can see the number is formed and is going to be written within the parenthesis with base 16. Now 1 is here, C is here, and A is here. So this becomes 1CA, and the remaining part which you left off is as it is, 1CA. So you will go from bottom to top, or you will write from right to left, that A will be the extreme right, then C will be the second part, and 1 will be the first part towards left. So you have to remember this method, and you can see that it can easily help you go through the methods. So I hope you will like this method. So keep watching.